And we're back in better than ever, still in 10.2, where we're showing you how to do mole conversions. In the previous podcast, we were showing you how to do conversions between grams, moles, and molecules. And now we're going to take it another step in our molar roadmap, where we're going to be converting from particles to moles to volume of a gas and back. And so let's go back up to our molar roadmap, see where we're at, and let's add another step to this thing. Make sure we're in our green color here. Our last step, or at least in this unit, our last thing that we're going to be converting in and out of is what is called the volume of a gas. And we're always going to be doing this at what is called STP. Now, what is STP? STP stands for standard temperature and pressure, which means we are going to be at 0 degrees Celsius and 1 atmosphere of pressure. Now, if that's not ringing a bell to you, that's okay. Everything that we're going to be doing in this unit will be at STP, so that's not going to be that big of a deal. However, you should understand the 0 degrees Celsius is your standard temperature, 1 atmosphere of pressure is your standard pressure. I do believe that's in the homework set and possibly on the quiz as well. Now, to go back and forth between the volume of a gas and the number of moles, we have to use what is called the molar volume of a gas. And that molar volume, 1 mole of a gas at STP, is going to be 22.4 liters. And I'll be showing you guys in class how big 22.4 liters is. It's probably not as big as you think that it is. Anyway, this particular conversion is used in the exact same way that the molar mass would be, to go between grams and moles, and Avogadro's number is between moles and particles. So let's go ahead and give this a shot. Let's go ahead and scroll all the way back down to example number 5, where we're going to be converting between particles, moles, and the volume of a gas. So here's our question. What volume in liters does, say, 1.5 times 10 to the 23rd molecules of hydrogen gas occupy? Alright, so we're going to be dealing with H2. So again, you're going to be starting with whatever is given. In this case, it is 1.5 times 10 to the 23rd molecules of hydrogen. And now to go between molecules and volume, if I scroll back up here, I'm going to have to go from molecules to moles, and then moles to the volume of a gas. So let's go ahead and do the conversion between molecules and moles. That's using Avogadro's number. So therefore, 1 mole of hydrogen is going to contain 6.022 times 10 to the 23rd molecules of hydrogen. Of course, the molecules unit of hydrogen are going to divide out. And now we're in moles. To go up to the volume of a gas, we're going to be using that molar volume of a gas of 22.4 liters of hydrogen for every 1 mole of hydrogen. And then, of course, the moles of hydrogen divide out top and bottom, and now we're ready to do the calculation, where we're going to have 1.5 times 10 to the 23rd divided by Avogadro's times 22.4 liters. And if you do that calculation, you should come up with 5.58 liters of hydrogen gas. So a little less than 3.2 liters of hydrogen gas at STP would contain that that number of molecules. Let's go ahead and try to go back the opposite way, where we're going to be going from volume of a gas to particles. So how many particles are in, let's say, a 2 liter of helium gas? All right. So we'll start off with our 2 liters. 2.00 liters of helium, and now we want to go back to moles. First moles, then to particles. So therefore, 1 mole of helium is going to occupy 22.4 liters at STP. The liters of helium will divide out top and bottom, and now we got to go to particles. Going from moles to particles is going to be using Avogadro's number, so 6.022 times 10 to the 23rd molecules of hydrogen for every 1 mole of hydrogen. Now again, how do we know what goes on top and what goes on the bottom? The units tell us. If we're in liters of helium first, you need liters of helium in the denominator. Now we have moles of helium up top. We need to have moles of helium. That should be helium, not H2. That should be He. Excuse me. He. The moles of He divide out top and bottom. And now you're ready to do the calculation, where you're going to take 2.00 divided by 22.4 times Avogadro's number, and if you perform that calculation, you should get 5.38 times 10 to the 22nd molecules of helium He. So that would be the number of molecules of helium that could fit in a 2-liter pop bottle at STP. So if you can see the calculations between volume, moles, particles, grams, they're all the same using that molar roadmap. So let's go ahead and give you a few sample problems. You can try them all on your own, and then we'll answer these and go over these in the next podcast. So here we go. The first one, how many particles are in 10 grams of water? And the next one, how many grams are in 5 liters of ammonia, which is NH3? And then finally, not how volume, but what volume in liters does 80 grams of carbon dioxide occupy? Go ahead and try those conversion problems, and we'll go over them in the next podcast.